Assalamualaikum warahmatullahi and good day to everyone. My name is Syakinah binti A Aziz. Today I want to present the Bachelor Degree Project 2. My supervisor name is Dr. Hambali bin Bojang. My project title is An Investigation on Surface Finish of Reproduced Motorcycle Component. Additive manufacturing (AM) and reverse engineering (RE) are critical in lowering time required for product development. In the application area of RE, it is frequently necessary to duplicate a part in the absence of original design or manufacturing data. Many attempts are made to control, monitor, and predict the surface roughness of the printed part surface. Surface roughness is affected by various parameters including layer thickness, print orientation, and print speed. Problem statement. In this project, an interview session was conducted with one of BMW Matric Club members. He said the original fuel flange is made of plastic. Uh, the the respondent has said the fuel flange connector comes from Germany. Once it's broke, need to be pre-ordered first around 5 weeks when to replace it. The material itself has a expiry date, can cause the fuel flange is broken. Life expectancy of fuel flange is minimum 5 years, but it depends to the rider how long ride on road. Furthermore, a fuel flange will be broken because of an accident. Based on the research, the price of fuel flange in the marketplace is expensive. The objective of this project is to reproduce the motorcycle component with good surface finish. Second is to analyze the surface finish between SLS and the 3 Pro anti-maker S3 for both the original component and prototype. Scope of this project is to do literature review, to scan motorcycle component, to carry out data manipulation of scan data, to create STL file, to produce a prototype of the motorcycle component, to analyze the surface finish of both the motorcycle component and prototype. We will move to the literature review. Motorcycle component, fuel flange. Motorcycle appear to be a fast and efficient mode of transportation for individuals. Fuel flange is the part of the engine that sends finely atomized fuel to the engine's combustion chamber under a lot of pressure. Reverse engineering. Reverse engineering is a producing a geometric CAD model from 3D point gathered by scanning or digitizing existing part or product. The reverse engineering method is a three-phase procedure, as shown in the figure on the right side, which is a scanning, point processing, and application. Third is computer-aided design. Three-dimensional computer-aided design, CAD, system based on a feature-based solid modeling approach. Computer-aided design CAD systems have been used in product development. Many fields of mechanical engineering, electrical technology, and architecture use CAD system to produce three-dimensional model, which serve as the foundation for later planning and manufacturing operation. The advantage of CAD is increasing the effectiveness and simple to use and to operate properly. The disadvantage of CAD is use of a computer-aided system in an unscientific manner and excessive reliance on the network. Additive manufacturing. Additive manufacturing is a procedure for creating three-dimensional things by adding a bilayer material layer. Additive manufacturing (AM) method, also known as a rapid prototyping (RP), are manufacturing that use a 3D CAD file to slice it into various thickness. The there are 4 types of AM process, which is a liquid process, molten filament process, powder process, and solid layer process. In liquid process, we have a SLA for the molten filament process. It has a fused deposition modeling, FDM. For the powder process, selective laser sintering, SLS. For the solid layer process, you have the laminated object manufacturer, LOM. The advantage of AM is direct manufacture from 3D CAD models. Digital file design may be freely shared, helping to modify and customize components. The disadvantage of AM is production costs and timelines and multi-material and multi-color development. The application of AM in other industry is aerospace and medicine. Surface finish. Surface finish measurement is required for a component during the manufacturing process, since the surface finish quality is known to impact the functionality of many elements, which is reverse engineering, computer-aided design, additive manufacturing, and measurement of surface roughness. We move to methodology. This is a project workflow on this investigation. The objective one was achieved when start a planning until a prototype. Meanwhile, the objective two is from prototype until analysis of surface roughness. I will go through one by one to explain this workflow. Literature review. Literature review for this project must be collected in various formats, including journal, paper, books, and conduct interview until getting enough information to carry on this project. All issues were discussed, such as the prior study on scanning setting, equipment limitation, the original of the motorcycle component. Uh, Identify the scan object. During Bachelor Degree Project 1, the historical artifact was selected at first as a scan object. But at present, COVID-19 has not subsided, so students are not allowed to come to the museum to do a project. Therefore, the supervisor was decided to use a motorcycle fuel flange as scan data. It is shown in the figure on the right side. The scan object aims to preserve the CAD data. Scanning. Non-contact scanning techniques were used to scan a fuel flange connected. A REX Scan CS2 Plus scanner was utilized to check the part during the scanning phase. The picture on the right side shows a solutioning REX Scan CS2 Plus. The perfect for monitoring a complex section with precision and accuracy in a demanding environment. This is a scanning procedure. It's shown in the table. Next is STL file. The file was converted to an STL file format, and the STL file was opened in SolidWorks to identify which part were not completely scanned due to the limitation of 3D scanner. The pictures show a STL file of scan data in the triangulation mode. If you can see inside the flange, there are some parts that cannot be scanned by the 3D scanner. That next is data manipulation. The primary goal of this method is to modify the triangle in the point cloud and add new features which are represented by the polygon into the point cloud. Next, Polywork by Innovatric software has been used as the tool for data manipulation of the scan data. The picture has a blue patch. The picture has blue patch is SAF file before import to the Polywork. The other picture is has complete edit in polywork. Prototype fabrication. The powder-based system machine used is SLS. This system use a laser beam or electron beam or to sinter or melt the powder particle to produce a complex part quickly. For the molten or filament process, two types of media were chosen, Ender 3 Pro and Ultimaker S3. This is a procedure for Ender 3 Pro machine. This is procedure for Ultimaker S3. Surface roughness test. The IPX104 portable surface roughness tester was used to measure the surface roughness of both the original product and the prototype made before it. Surface roughness measurements have been carried out on the selected three directions of the original product and the prototypes. It's shown in the figure below. Result and discussion. Development time result. As you can see the table below, the fuel flange connector prototype development time was taken from the scanning process and end up with a post-processing process. The scanning process took 16 hours to be complete. The factor that influenced the scanning process time taken is the fuel flange connector has a difficult area to scan such as straight and hole. Comparison of surface roughness. The comparison of surface roughness was carried out based on the average surface roughness reading of the original component and the prototypes. The table shows the result of average surface roughness reading of the model. The unit for surface roughness reading is in micron meter. This table to represent the difference between the average surface roughness reading and the original item. This histogram of percentage difference to original product has been used to show how much the average surface roughness reading have been changed. As the result, the surface roughness of the prototype is growing rougher and the RF value is increasing. The parameter setting for each machine is different so that the surface quality will be different. Based on the comparison by the surface finish, there are two machines, Ultimaker S3 and Ender 3 Pro produce a better surface finish than SLS machine. Conclusion. This project has achieved the two main objectives. The first objective was performed when 3D scanning process was done, then convert to the STF file format and data manipulation and do a verification of the file. Before printing, the parameter was set, such as the layer thickness, build orientation, and part orientation to ensure the prototype were in a good surface finish. The result of the based on the result of surface roughness measurement, the expectation of this project, which is the surface finish of the prototype, is similar to the surface of the original part that is not achieved. The surface roughness of the actual fuel flange differ from the prototype due to the different material and different way of manufacturing. Among the three types of AM technologies that used in this project, the SLS machine produced a rougher surface and the 3 Pro machine produced a partial good surface. Meanwhile, the Ultimaker S3 produced a good surface finish. For future development regarding in this project are several recommendations. First, for SLS, use a new powder to produce prototype because it can increase the quality of surface roughness compared to recycled powder. Second is do not print a multiple prototype simultaneously to reduce the risk of printing error. The last one is select an appropriate part orientation to provide the prototype with a good surface finish. Thank you. That's all from me.